Transformers. In the United States alone, there are over 50 million pole-top distribution transformers in service. Every year, 3 to 5% of them are re-energized, making it one of the most common operations for linemen. Lightning is the leading cause of transformer failures. Other causes include manufacturer's defects, mechanical damage, and different current-related failures. Pole-top transformers are usually connected to the primary supply network by a cutout fuse. The cutout fuse will operate when there are fault currents from the distribution network or evolving faults within the transformer. If these overloads result in permanent damage to the transformer's internal components, an internal fault has occurred. A fault can produce several types of gases that, when mixed in particular proportions, can become explosive. When a fault occurs, there is a sudden increase in tank pressure, and these gases collect in and above the oil. If the internal fault is undetected and the transformer is re-energized, the risk of explosion increases. The explosion seen here is an example of one of the hazards line workers may face when re-energizing transformers that have an internal fault. To reduce the risk of significant events, utilities have developed thorough but time-consuming procedures. Unfortunately, these procedures are not always followed because of the urgency to restore power quickly. Industry studies conclude that 1 in 5 transformer re-energization operations involves a transformer with an internal fault. To identify faulted transformers and enhance line worker safety, IFD Corporation developed the Internal Fault Detector, or IFD. The IFD sensor is a mechanical device requiring no electrical connections. IFDs are inexpensive to purchase and are easy to install in new transformers during manufacturing. They can also be retrofitted in existing transformers. When installed on the side of a transformer above the oil level, the IFD does not interfere with any of the electrical components inside the transformer. The IFD serves a dual purpose, as a pressure relief valve, or PRV, and as a fault detector. During hot days or under heavy loads, the transformer will heat up, and the pressure inside the transformer tank will gradually increase. As the pressure gradually increases, it can equalize on each side of the IFD's diaphragm through a metered hole. When the PRV activation level is reached, the PRV opens, allowing air to escape. It closes when the pressure is reduced. The IFD PRV can also be operated manually, just like other transformer pressure relief valves. When an internal fault occurs, the pressure increases suddenly. In this case, the metered hole in the IFD will not allow the pressure to equalize on each side of the diaphragm. Instead, the diaphragm moves up, releasing the locking pin, and causes the highly visible orange fault indicator flag to pop out of the side of the transformer. By simply looking up, the line worker can see that the transformer has an internal fault and must not be re-energized. An IFD-equipped transformer with the highly visible flag displayed must be taken out of service and replaced. The flag has been designed for easy identification in daylight and in the dark with a flashlight. Note that the orange indicator flag cannot be reset. If the cutout fuse is open but the IFD is not activated, chances are the transformer is okay to re-energize, providing all normal fault checks are done. Nothing can be considered 100% when it comes to safety. Installing IFD-equipped transformers is almost identical to other transformers. The only difference in the process is the removal of the shipping lock once the transformer is mounted. Remember, the shipping lock must be in place when transporting or handling a transformer with an IFD installed. The newest model of the IFD is a one-size-fits-all version that is applicable to single and three-phase pole-top and pad-mount transformers, as well as voltage regulators. It improves customer operations and handling and integrates more seamlessly with transformer manufacturing processes. The benefits of this new model include one-size-fits-all unit for single and three-phase pole-top and pad-mount transformers and voltage regulators, certified for use with ester-based transformer fluids, reseals after activation, preventing any oil spillage while removing a faulted transformer from service, improved shipping lock, easier to remove and install, faster and easier installation at transformer manufacturers. When a significant event occurs, related costs could include occupational health and safety worker wages, legal costs, environmental damage, cleanup costs, asset replacement, as well as potential fines and negative public relations. The IFD's highly visible indicator flag allows for rapid and reliable detection of internal faults. The benefits include increased line crew productivity, improved network reliability and customer service, extended asset life, avoidance of environmental damage, and of course, increased job safety. As modern utilities strive to continually improve the efficiency of supply networks, the implementation of IFDs is the key to enhancing the safety and performance of your distribution network. For more information, consult the IFD website at www.ifdcorporation.com.